Hi, this is Chuck Benedict, mentor for Team 997 in Spartan Robotics in Corvallis, Oregon. Actually recording at an undisclosed location. Actually, I'm in Washington. I'm staying with relatives, but I thought I would record a few more videos and spend my time that way. So in my ongoing series on building a device driver for WPI and the roboRio for a color sensor, I thought I would walk through the code that I developed, so you can get a sense of how this code is written, what it does, and so forth. And I guess starting out, it was made real easy for me because there's an author that already wrote I'm not going to call it a device driver because it actually doesn't report um, information up to the Linux kernel, but it does essentially everything that we need. So I decided to borrow it. So it's from a project called Raspberry Coffee. Oliver LD is the repository name. So thank you for this work. First off, when we take a look at this project, and I'll have the links to all the stuff in the comments so you can look at it later. The first thing to note is that there's an import to com Pi4J, which obviously that's for the Raspberry Pi, and those are some classes that we're going to have to factor out. And specifically, this is for the I2C bus, which makes perfect sense because for the roboRio, we want to use the WPI I2C classes. So that's understood and expected. Next thing, on some prior videos, you may remember me talking about what writing a device driver sort of means for the roboRio, for WPI in particular. The classes that you write implement sendable base. So this class here will need to implement or extend that class and implement a method to be able to write data to the smart dashboard. So we know that's work that's got to be done. Next thing, which is really nice, is reading the data sheet. There are tons of flags and addresses and things that you need to reference in code, and you generally don't want to have to do that. Reference those constants specifically in code because that gets really messy and you don't know what the heck it is after going back and looking at it. So the author very nicely put all these constants in here, which is a real pain. So that saves a lot of work. Okay, next thing. Some private member variables of the I2C bus and the I2C device, which is, they just named it the same as the color sensor, which is fine. Those two obviously are going to have to get factored out and replaced. Then there's a whole bunch of constructors, which are fine, but of note, there are some constructors that I plan to add because testing is a very important thing to me, and to be able to test this class, both unit and integration test, is important. And in order to do that, you need to be able to pass in dependencies. Don't count on your class creating those dependencies internally. Pass them in from the outside so that you can mock them out in your tests. And you will notice that there is no way, none of these constructors take an I2C port as a dependency. The constructors, in fact, you can see right here, I2C factory get instance, they build the reference to the I2C bus inside the constructor. So I'm probably not going to take these away. I'll probably modify them and then add a constructor to take a reference to an I2C bus. Next thing of note, the initialize function. I talked about in prior videos looking at data sheets of devices like this color sensor. There's usually a way to identify the sensor so that you know that that's the device that you're talking about. And it's always a good idea when you write these device drivers to do that kind of a sanity check to just make sure that you know what it is that you're talking to before you start talking to it. And you can see the author has already done this. So they do a read U8, which is unsigned integer for 8 bits, giving this ID command, which if you recall from the last video, that ID command was, I believe, hex 12. And I'm going to go see if I can find, yeah, here it is right here. So hex 12 And the author even put the note that you should get a response of 44 for a TSC34725. So back down to the initialize, we do a read on with that command, and we're actually looking at hex 44 and returning, I guess -1 means failure. So this is where the sanity check comes in real handy, and that way you don't proceed if you don't get what you expect. Now, this author chose to sort of go old school with C type responses, where you return a Boolean or something, whether if a method succeeds or fails. I don't like that style. I think it's just, I don't know, it's just old. So I'm going to change some of these things to throwing exceptions so that the author can catch exceptions and take action, as opposed to have to put a whole bunch of ifs in their code. You know, if this succeeds or if this fails, then do this. That's just kind of nasty. So that's another change that I will be making. So finally, if we scroll down here and, well, obviously get raw data, this is sort of the meat of the whole thing. This is where we're getting our red, blue, green, clear values, and we're calling this function readu16 to do it, which is fine. What that means to me, we've already seen a readu8 and now a readu16, and here we happen to see a write 8 where we are setting the gain on the device. So those are 3 functions that I already know of that potentially are going to require modification. So why don't we go find those? Here we go. So here's the write U8. It takes the register to write, and it takes a value, and it writes to that TSC34725. That's actually an I2C device instance variable, calling the write command on it. So this for sure is going to have to get touched when we modify the new code. Likewise, in the readu16, in this case, the author does 2 U8 writes, two U8 reads, which might be fine. That seems like that's a little bit inefficient. Maybe we can do this in one read. So we'll kind of check into that, but at least this makes this function is a dependency on readu8, and so we might not actually need to modify this one at all. So here's readu8. Again, going back to that I2C variable, doing a read command on it. So that's really, there's a lot of supporting code in here. This TSC color class is nice because it sort of wraps up all the values for you and puts accessor functions, which is fine. There is a static main class, which does a little bit of sanity checking. This is kind of the author's way of doing testing, I suppose. It's okay. I prefer to just write tests separate from the driver, because then that way this code doesn't get intermixed in with the driver. And after all, we're writing a library class here, we're not writing a program. So putting them, anytime you see the main function in a class, you think, oh, this is a program, even though, in this case it really isn't. So I tend to not like to do this, and I'll probably factor this method out. Okay, so enough of looking at old code. Why don't we go look at new code? So I have a project that I've created. Again, the link to the project is on our GitHub site, and I will put a link to that in the comments. I essentially just took the old code that we just looked at and I copied it over, and started my modifications. I did put a whole bunch more comments in the class, and I'm putting in java.comments, which allows you, when you hover over, to be able to read function descriptions and so forth, which I find really helpful in VS Code, and put the links to the various products and so forth here already. So I mentioned that sendable base had to be implemented, so I'm extending sendable base, and we'll take a look at the function that we have to override here in a bit. Pretty much left the constant declarations alone because they all seem fine. I mentioned that I had to jigger with the constructors a bit, which I did. And of note, so here's where we're substituting in WPI variables. So, the references to the old Raspberry Pi I2C stuff, that's all been taken out. In fact, if I go up here and look at the imports, you can see that my imports, I took the Pi4J stuff out, and I basically put the references into the WPILibJ up here. So anywhere where we had references to I2C, they now reference WPI. And in particular, this constructor here, if you just instantiate the class with nothing, with no parameters, this is the method that's going to get called, and it's going to default to the onboard I2C port on the RoboRio. And there are two I2C ports on the RoboRio. There's a 4-pin I2C port all by itself, and then there's a 25-pin expansion header that has a whole bunch of different ports in it. One of them is an I2C port, and there's a constant that's defined on the class, on the WPILib class, that references that second port. I've chosen to just make the onboard, the little standalone port, be the port that's defaulted when you call this function. There's also a verbose parameter. It's an optional parameter. Java doesn't really have that, but this sort of makes it a parameter array that can contain 0 parameters. So I use it like a optional parameter. But if you pass true at the end of any of these constructors, then the driver will spit out a bunch of helpful info to the system log that on the driver station you can take a look at to see that the driver is doing something. I tend to write out reads and writes to the driver, so it actually tends to be pretty verbose to the log, but it does allow you to see what's going on. So I created some additional constructors to allow you to set the integration time and the gain. If you don't know what that is, I talked about it in prior videos. Go read the TSC data sheet, because it describes those in some detail. But having them on the constructor saves some steps to having to set them to other values. The additional constructors then that I said I would create, here they are. So this constructor is sort of like the first one we look at, except you pass in an I2C, an already instantiated WPI I2C port. And then, of course, you've got the verbose parameter. But then in the act of doing this, that allows us to mock up this I2C port to our own specification, which when I cover the testing video, I do that exact thing. And a little sneak peek, even though I'm not going to talk about it here, I use the bus pirate to swap out WPI read-write calls and swap in calls to the bus pirate, so I can basically test this stuff without having to have RoboRio. So watch that video. That one's really interesting. Okay, as far as the rest of the code goes here, let me see if I can find some interesting bits. So one of the things that I noticed, and I found this through my testing, I think there was already a disable function in the author's original driver, but when I started writing tests, I found that the disable function didn't work, because when I reread in the enable register to check the value of what I expected, which the value is 0 if it's all disabled, I wasn't getting it. And I reread the data sheet again, and just like enabling the device, you have to disable it in 2 steps. You have to turn off the AEN flag, and then you have to do a power off to the device. So I made that minor change to disable testing. Very helpful. So let's keep going. Let's go down to the functions that actually read and write to the port, so we can see what's been done there. Okay, so in the write8 function, that's where I factored out writing to the Raspberry Pi I2C class, and now I write to the WPI write class. Interestingly, it's takes the same arguments, so there was very little work that I had to do. Basically just change the reference and I was done. read U16. So if you'll recall, they did that in 2 read 8 steps. I modified that a little bit to just do 1 read. I just thought that was more efficient. And also, I am throwing exceptions. So you'll see, I didn't cover this above in the constructors, but you'll see places in this code now where, I don't return true, false, did this work or not. I throw exceptions so that you can catch them and take action. So there's my 2-byte read for U16. Read U8, same deal. I just make the call to the read function on the I2C class and throw an exception if there's a problem. Finally, the sendable base class that we inherit, that we extend, requires a method to be implemented on it called init sendable. And that method does 2 things. It sets up a call. So down below here, when you call SetUpdateTable, you're creating an anonymous function, and that anonymous function gets called automatically by WPI and on the roboRio periodically. I don't know how often, but automatically it gets called multiple times a second, which allows you to make a call to your sensor to pull data from it and push it into network table. And so in here, you can see my network table entry. I'm setting a smart dashboard type of RGB color sensor, and the entries are R, G, B, and C. And then in the SetUpdateTable function that I create, I am setting up or calling the raw data method call, and I get back a TSC color object, which is that object that I mentioned a little while ago that has all of the variable or values available to you. And I just do a set number call then on the network table entries that are up above here. And if I catch an exception, I just write 0. That seems logical to me. Okay, so I think that's really it. I created, in order to make this work, so this is a library, and so when you create in the WPI plugin for VS Code, when you create a new project, that creates a robot project for you, which that's not what this is. So I didn't use the WPI plugin to create this project. I basically just from scratch created a Java library. I think actually the Gradle, and I can't remember now, but I think the Gradle application has a way to create some base templates. One's called Java library. Let's go into build Gradle and just take a quick look at this, because it might be useful to just know a little bit about how to do this if you're going to build your own library. So Java library is the default plugin that has very basic bits in it for building a Java library application. So that allows you to, run the compile. It hooks up automated testing automatically for you. It's got a clean function so that it cleans the build directory out and some other stuff. Because we're making calls to WPI, and specifically we're calling into Java, and there's some JNI, Java Native Interface stuff, because we're calling the guy, I can't remember the name of it. Sorry, the lower layer of the roboRio. You have to have native DLLs, or in this case, I'm running on a Mac today. You have to have the native Mac loadable libraries. So the GradleRio plugin wires up all that stuff for you. So I have a link then to GradleRio to allow that to happen nicely, automatically. The Maven Central repository you need access to, because this project automatically downloads the stuff that you need from Maven. So you have to have a reference here. And I think this was already here when this was created. A nice manifest, or a very basic manifest, is created here for you by filling in project name and version. And these come from settings.gradle. So there's my project name. And then finally, the dependencies that I've declared, and I have a few here. So JUnit, which is, it's a standard testing framework that has a runner for VS Code. I've talked extensively about using JUnit in videos past. I am going to talk some more about testing this project here in another video where I use some additional JUnit features. Mockito for our mocking framework. Truth, so that we can make our tests a little more natural languagey, so you can read them better. Pure Java COM, this is a serial communications framework, which seems to work really well. And since we're talking to the bus pirate, that allows us over serial port to do that. And then Hamcrest is another assertion type library to make assertion more English-like. So that's kind of a tour of the project. I'm not going to build it or test it or anything. I'm going to save that for another video because this is going on pretty long. But hopefully you found this informative, and I thank you for watching.